Hi, my name is Amil Ahmad Sofi, and today I am going to teach a topic of physical science, and that is light. Today we are going to learn something about light, and our main objective would be what is light, what is the nature of light, what is reflection of light. First of all, I would like to give a definition of light. What is light? You can see here, light is a form of energy which enables us to see the things from which it comes. Light is a form of energy. It enables us to see the things from which it comes. Whether anything gives its own light or it reflects light, we are able to see the thing. We are able to see the things from which the light comes. On the basis of a light given by an object or light reflected by an object, there are two types of objects. That is luminous object and non-luminous object. What are luminous objects? Luminous objects are those objects which have their own light. For example, sun, stars, bulb, candle, all these things which I have discussed, they have their own light. That is the reason they are called luminous objects. On the other hand, you can see the definition. Non-luminous objects are those which do not have their own light. They only reflect the light of luminous objects, and because of reflection of light, we are able to see those objects which are non-luminous, which do not have their own light. Now, I will give you some examples of non-luminous objects. You can see this whiteboard, it is non-luminous because it does not have its own light. Moon is non-luminous. Similarly, chair, table, these curtains, walls, stone, brick, mountains, all these things are non-luminous because they don't have their own light. So this was something about luminous and non-luminous objects. Now we have another term, that is nature of light. We have given the definition of light, what's light. But now we are going to discuss what is nature of light. As far as nature of light is concerned, two theories have been given to describe the nature of light. First theory is called wave theory of light, and second theory is called particle theory of light. First of all, I would like to say something about wave theory of light. According to wave theory, light is composed of, or light consists of electromagnetic waves which do not require any material medium for their propagation. In fact, they can travel in vacuum. And the light, according to wave theory, travels straight with a speed, very high speed of 3 into 10 raised to power 8 meter per second, not kilometer, sorry. 3 into 10 raised to power 8 meter per second is the speed of light. And it is wavelength. It is wavelength according to wave theory. Its wavelength is in the range of 4 into 10 raised to power minus 7 meter to 8 into 10 raised to power minus 7 meter. 4 into 10 raised to power minus 7 meter to 8 into 10 raised to power minus 7 meter. This is the speed of light, and this is the wavelength of light. We are here discussing first wave theory of light. So, according to wave theory, light travels in the straight line, and it consists of electromagnetic waves. What are electromagnetic waves? Those waves which do not require any material medium for their propagation. So this was something about wave theory of light. Now let's come to another theory of light, that's particle theory of light. You check it on the board. What's particle theory of light? According to particle theory, light travels very fast and consists, the particles are energy packets, and those energy packets are called photons. And the speed of the light is same as I have discussed, 3 into 10 raised to power 8 meter per second. So this is particle theory of light. The phenomena of diffraction, polarization, and interference can be explained only when we consider light as a wave. On the other hand, the phenomena of reflection, refraction, and casting of shadows by objects can be explained when we consider light as a particle. The modern concept which combines both the theories, that's wave theory and particle theory of light, that's called quantum theory of light. Quantum theory of light explains both wave theory of light and particle theory of light. On the basis of quantum theory, we can say light has a dual nature. That is, it sometimes acts as a wave and sometimes it acts as a particle. Now we have another term, that is reflection. When light falls on any object, three things may happen. Either light may be absorbed, or it may be reflected, or it may be transmitted. What is transmission? When light travels from one medium to another medium, we say transmission has taken place. When light is absorbed by some surface, some material, we say it has been absorbed. And sometimes a fraction of light is reflected as well. So that's called reflection of light. We are here to discuss the reflection of light. Absorption and transmission we will come to know later on. So right now I'm going to give you some definition of reflection of light. What is reflection of light? The bouncing back of light rays from the surface is called a reflection of light. Or we can say the change in the direction of light rays in the same medium is called a reflection of light. I'm explaining it like this. Suppose this is a plane surface. Now a light ray falls on it. This is the light ray. So I denote light ray AO. So let this light ray falls on the surface. I will name this surface X dash. So this light ray, incident light ray, falls on this surface and it is reflected back by making some angle. It is reflected back. So I can say, let's consider it is reflected along OB. O is the point of incidence and this is AO is incident ray. I will write it. Incident ray. Incident ray. OB is reflected ray. Reflected ray. Now X dash is a plane surface. I will draw a perpendicular at the point of incidence of light ray. Perpendicular, that is known as normal. If I draw a perpendicular at the point of incidence where light ray falls, that's called a point of incidence. Here I will draw a normal, or we can say perpendicular. That perpendicular is also called normal to this surface. Now this is the case of reflection of light. Light ray comes along AO and then it goes after reflection OB in this direction. So this is reflection of light. So bouncing back of light rays from a surface is called a reflection of light. So this light ray is bouncing back along this direction. Or we can say the change in the direction of light ray in the same medium is called a reflection of light. Change in the direction of light ray in the same medium means, suppose this light ray is in air and it goes again in the air. It does not change its medium and this is called a reflection of light, as I have shown it. Now the reflection of light follows two laws. First law of reflection and second law of reflection. Those two laws I am going to explain. According to first law of reflection of light, the incident ray, the reflected ray and the normal lies on the same plane. If we consider three rays as this is one incident ray, it is a reflected ray and it is normal. If we put them on a plane surface, they all will lie on the same surface. So incident ray, reflected ray and the normal lies on the same plane. This is the first law. Now according to second law, the angle of incidence is always equal to the angle of reflection. What is angle of incidence? Angle of incidence is angle between incident ray and normal. This is incident ray, this is normal. The angle between incident ray and normal is called angle of incidence. The angle between normal and reflected ray is called angle of reflection. So according to second law of reflection of light, the angle of incidence is always equal to the angle of reflection. It means that if angle of incidence is 30 degree, obviously angle of reflection would be also 30 degree. If we change angle of incidence from 30 degree to 20 degree, automatically angle of reflection will also change. It will also become 20 degree. That means the magnitude of angle I is equal to the magnitude of angle R. So value of angle I is always equal to value of angle R. That means angle I is equal to angle R. This is second law. So according to second law, angle of incidence is always equal to the angle of reflection. This is second law of reflection of light. So we have discussed both the laws of reflection of light. Now we will come to another term, terms of light.